Hi guys, how are you doing? Let's hope you are doing great. As you see here, we have a question that is the integral of sine square x times cosine of 3x using complex numbers. Here, we want to use complex numbers to solve or evaluate this kind of integral. I want you to keep watching. If you didn't subscribe to our channel, I recommend you to subscribe on it. Okay, let's keep watching till the end of this video. Okay, an integral of sine square x times cosine 3x dx using complex numbers. As you know, it is not easier to integrate using complex numbers, but here we will use Euler. As you know, sin theta can be written as exponential of theta I minus exponential of negative theta I over 2I, while cosine theta is equal to exponential of theta I plus exponential of minus theta I over 2. The sine of 2x or something which is called theta, but here we have sine squared x. As you see, x will be replacing theta here, and this is equal to exponential of xi minus exponential of negative xi over 2I for 2. This is equal to exponential of xi minus exponential of minus xi over 2I. Let's share both numerator and denominator. This is equal to, as you know, the square of I is negative 1. That's why this denominator will be negative. Okay? Here is exponential of 2xi minus 2 times exponential of xi times exponential of minus xi plus exponential of minus 2xi over minus 4. Here, the square of sine x is equal to minus 1 over 4 into this will give 1 because the exponents are of different sign but they are the same. So, as you know, when multiplying the powers with the same base, we add up their exponents. Okay, this is equal to exponential of 2xi plus exponential of minus 2xi minus 2. Here, cosine 3x, as you know, this will be put in theta here, and even here. Okay, this is equal to exponential of 3xi plus exponential of negative 3 xi over 2. So instead of integrating a list using this and this, I recommend you to integrate using this and this. These are the forms of complex numbers. So an integral of sine square x cosine 3x dx is equal to the integral of, let's use this, minus 1 over 4 times exponential of 2xi plus exponential of minus 2xi minus 2 times exponential of 3xi plus exponential of negative 3xi over 2, then dx. As you see, we'll be having an integral of, let's multiply this and this. This and this will be minus 1 over 4 times 1 over 2, and let's multiply this. From the fact that a n times am is equal to a n plus m. Here the base is a. This times this will be exponential of 5 xi. This times this will be plus exponential of minus xi. This and this will be plus. Here is, what is this? Here is this, and this will be exponential of xi plus this, and this will be exponential of minus 5 xi. This and this will be minus 2 times exponential of 3 xi minus 2 times exponential of minus 3xi, then dx. This will be an integral of, let's use this, will be having minus, let's select minus 1 over 8 here, and this integral, because we are going to integrate element wise, this is what we are going to do. Remember, an integral of e exponential of ax dx is equal to 1 over a times exponential of ax, then adding a constant. As you see, here we'll be having 1 over 5i times exponential of 5xi minus, here will be only minus. We have 1 over I times exponential of minus xi. Let's add here, we have this. What we have is 1 over I times exponential of xi. Here, let's have, because this is minus, we have minus 1 over 5i times exponential of minus 5xi. Okay, here is, what do we have here? We have minus 2 over 3i times exponential of 3xi, and here will be positive because this is negative, and this we have positive 2 over 3i exponential of xi, then a constant, then add a constant here. Okay, so what we are going to do is to collect terms with exponents of different sign but looking the same. Example, this and this, this and this. We have minus 1 over 8 times this is exponential of 5xi minus exponential of minus 5xi over 5i. Okay, does it sound well? Let's come here, count this, but here is minus, I guess. Okay, let's start with this. Let's start with minus 2 into exponential of 3 xi minus exponential of minus 3 xi over, what is this? 3i will remain with this and this. Let's start with positive. Plus, we have exponential of xi minus exponential minus xi over, here is I. Then add the constant. We'll be adding a constant c. Hope that is clear. Let's hope it's clear enough. Okay, I can be back writing 1 over 8 as minus 1 over 4 times 1 over 2 into this exponential 5ix minus exponential minus 5ix over 5i negative 2 times exponential 3xi minus exponential negative 3xi over 3i plus exponential of xi minus exponential minus xi over 2 plus a constant, some constant. Okay, I'll be taking this 2 inside here. I'll be having minus 1 over 4 into 1 over 5 times exponential of 5xi minus exponential minus 5xi over 2i minus 2 times exponential of 3xi minus, let's set here 2 over 3 minus exponential negative 3xi over 2i plus, here is exponential of xi, but here is I as here minus exponential of minus xi over 2i plus a constant of integration. As you see, if you remember this well, because here is minus, here is minus, here is minus, I want you to look at this. Everything here is of the form exponential of I theta minus exponential of minus I theta over 2i. That's what is here. So I have minus 1 over 4 into, as you see, this will be, because our theta is 5x here, we have 1 over 5 sine 5x minus 2 over 3 sine 3x plus sine x plus a constant. So, as a conclusion, that integral, the given integral will be this. So, conclusions, integral of sine squared x cosine 3x dx is equal to, multiply this and this will be minus 1 over 20 times sine of 5x minus this and this will be only 1 over 6, but this times this will be positive 1 over 6, but here is positive sine 3x minus 1 over 4 sine x. Then let's add a constant. Don't leave our channel without subscribing. Don't leave it without sharing, because you are very important. Thank you very much for watching, guys.